All right, so we are through navigation. You should have taken the navigation formative. I'm still waiting on a couple from some people. That is still open for you to take. So if you haven't taken the navigation formative, or if you took it and you didn't get 100% on it, it's still open for you to try your second try on that one. So that puts us through yesterday. Then, today we're going to start 6.1, vector operation, or intro to vectors today. Okay? And that's going to take us through next week. Okay? So, today and tomorrow we'll be in class, so we'll be doing stuff out of our purple packet. Okay? If you have off tomorrow and you want to, actually, you guys are going to be here. What am I talking about? You guys, if you're off tomorrow and want to join one of the classes, the list of the times when classes are is on the It's Learning page for you to join in if you want some more vector work. Okay? But then Friday, so sometime after tomorrow's class, before next Tuesday's class, there's a video for you to watch on multiple forces. It's a very good intro video to what we're doing next week. Okay? It's an example in your packet. We also give you the answer to the first one so that you can try that one on your own. There is also a formative this week. It's going to be on vector operations. Okay? So after today, you are pretty much guaranteed a 5 on the formative. Okay? It's out of 10. You're pretty much guaranteed, you'll be guaranteed a 5 if you understand today's stuff. Okay? Then next week is going to be vector application. So we're going to be getting back into word problems, dealing with vectors and multiple forces and things of that nature. Okay? I will not be in class next week. Okay? I'm on the scholarship committee, and we're doing scholarship interviews next week. So Mrs. Hill and Mr. Roth will, if you see one of them instead of me, don't be freaking out. I'm just downstairs interviewing kids. Okay? But with that being said, your next test is going to open on probably March 23rd. We'll probably actually open it at 3 o'clock on March 23rd. But that's the last week before spring break. Please, please, please. If you're going somewhere, be safe. If you're not going somewhere, be safe. But either way, we want you to do that before spring break. So that one's going to close on the 26th. Okay? So we're going to give you Wednesday, Thursday, and Friday to do that test. Okay? It'll be a 2-parter again, like normal. Okay? But we want you to do that test in that time frame because you'll do much better on it by taking it then as opposed to waiting until the end of spring break to take it when you haven't done this stuff for a week and you've been just kind of relaxing. Okay? All right? So we got that going. All right, let's dive in. We are on the page in your purple packet. 6.1 vectors in the plane is what it looks like. Okay? 6.1 vectors in the plane. Here we go. So we're going to talk about vectors. And vectors are used to represent quantities that have both magnitude and direction. Okay? So we've got that going on. In general, a vector is a directed line segment. And now this is what you are going to have to fill in here. So let me get a little highlight action going on. I think you start with width. So highlighted, you need to copy in, actually no, this F breaks. So copy this in right on your page. Right? Yep. So the component form of a vector. So a vector, what's my vector, Victor? Has its tail has its tail at the origin, if it's in standard position, and the head of the vector is at a specific point. Okay? So the tail is at the origin, and the head is there. But it doesn't have to necessarily be that way. Okay? It could be somewhere off in the middle of space, and we'll find out here in a few minutes how to find the component form of any vector. Okay? So notice that it's kind of like the parentheses with a point, but they're like almost like half a diamonds. You know what I mean? I don't know really what to describe those as. Okay? But don't write them as parentheses, because parentheses mean something different. Parentheses would be a specific point. Vector is it's at a specific angle with a specific length. Okay? Good with that? So the magnitude then of a vector is the vector's length. The direction is the trig angle. We're going back to trig angles for this week. Names, usually it's a lowercase letter. Okay? But sometimes you might also have 2 points, where P is the tail of the vector and Q is the head of the vector. So there are some times when you might have it written out in 2-point form. Okay? But most of the time it's going to be in a lowercase form. And then the symbol is that arrow, and if you do the two-sided arrow on top, we're okay with that too. Okay? But the symbol then, to signify that, would be with that arrow. In print, okay, if you can italicize, it would be italic. Okay? It would also be italic. Okay? So the trig angle is from 0 on the unit circle. That means that we're going, here is 0 degrees, here is 90, 180, and 270. Just to confuse you even more with trig angles. Okay? Okay? One big rule when we're doing some vector calculations, it's always head minus the tail. Okay? Head always comes first, tail always comes second. Okay? So we can represent a vector anywhere in space. Okay? So this is at the point, we'll call it O, which is our origin. We can tell if vectors are equivalent or not by getting them, if we adjusted them to standard position. So that's where the head minus tail rule comes in. Because yes, this is here, but if I adjusted it down here, it would be the exact same thing. And let's show you how that works out. So what I'm first going to do is I am going to first represent vector RS. And it's written RS because R is the tail, S is the head. If I wanted to call it some other letter, like A, then I would call it vector A, like that. Those two are going to represent the same thing. So the head minus the tail would be, I would take the horizontal component of the head minus the tail. So that's like the x part. I would take x minus x, head of x, or heads x minus tails x. And then I would do the y, the vertical part, 6 minus 2. So that's going to give me the vector 3, comma 4. Now, if my vector is in standard position, like, let's say, vector B here, vector OP, or vector B, I can just go directly to the point of the head, because it would be 3 minus 0, and it would be 4 minus 0. So these two vectors are said to be equivalent vectors because they're, what was the word again? What's the word I'm looking for here? Component. All I could think of was conjugate. Their component forms are the same. I think it's ENT. ENT or is it ENT? ENT. And it's, oh man, I spelled this one wrong. It's AL and EN. Right? Spelling was never my strong point. I think that's good. Okay. So we need to show that vector RS is equivalent to vector PQ. Well, vector RS is going to be -1 minus -4, comma, 6 minus 2. Because S is the head, so that's the one that I take for that one. And that's going to give us our vector 3, 4. This, I think, this is just off to the side on your purple pen. And then we need to find vector PQ. So that would be, I would take 5 minus 2 and 3 minus -1. 5 minus 2 is 3. 3 minus -1 is 4. So these are equivalent. Because their component forms are the same. Okay. Good so far? Sweet. Here we go. So suppose that vector V is the vector -2, 5, or has a component form of -2, 5. Then we need to find the opposite of V. If I were to draw out vector V would be somewhere over there. Right? Because it would have a horizontal component of -2, so I'd go left 2. It'd have a vertical component of 5, so I'd go up 5. Right? The opposite of that is going to go in the opposite direction. Okay? So instead of it going up and to the left, the opposite of V is going to go down and to the right. But it's going to have the same length. It's going to have the same magnitude. Okay? The direction is going to be off by 180 degrees. Okay? So one way of doing that is we just negate the horizontal and the vertical components. Okay? Think about it. Kind of like the distributive product. You distribute that negative sign into the vector. Okay? And that will give you the opposite vector. Okay? Going too fast. Again, I feel like I'm running a sprint and you guys are just kind of walking a 5K. I'm sprinting. Let me know if I'm going too fast. So suppose we've got U and V. So U, I'll put in red, is the vector -2, 5. This one, that one, that color. So there is our vector. We will call it Then we've also got vector V. Vector V goes through the point 3, -2. I have no idea why the vector hierarchy has chosen U and V to be the names of their most common vectors. To me, that doesn't seem very smart because they look so much similar, U and V. But that's what they do. Okay? So if I were to add those two vectors together, U plus V, I would add the horizontal components. So we'd have -2 plus 3, 5 plus -2. -2 plus 3 is 1. 5 plus -2 is 3. So the resultant vector is the vector 1, 3, which would be right there. Now, here's the cool thing. Watch a little mathematics trickery. If I went head to tail, oops, I went off by 1. Duh, Linz, come on, you're better than that. Here I was all excited, and I only went 2. do some mathematics trickery. Okay, come on now. So I kept angle or vector v the same, and if I go head to tail with them, I end up at u plus v. Or if I go head to tail with them, I end up at u plus v. Okay? So if you're adding vectors and you're graphing them out, you can extend them out and just go one right after the other. So you could plot vector u and then plot vector v from the head of vector u, and that would give you the vector u plus v. Okay? Or vice versa. That works out. Kind of cool. Okay? Or you can just do it the algebraic way and just add the horizontal components and add the vertical. Okay? So let's suppose that vector v is the vector 3, comma, negative 2. So if that's the vector 3, comma, negative 2, that would be out here somewhere. Right? Well, the vector 3v is the vector three times longer, but in the same direction. So it's kind of like adding on to that vector. And you just keep going. There's 2 times as long. Bad. And you end up there. Yeah. So each time that we go on here, so we went out, so there's my horizontal component of 3. Well, then I went out 3 more, and then I went out 3 more. So all told, how far did I go out? I went out 9. And then vertically, I went down 2, and then I went down 2 more, and then I went down 2 more. So how far down did I go? 6. So it should be the vector 9, comma, negative 6. Well, the easy way of doing that is you just take 3 and you distribute it in like we distributed it in the negative sign, like I showed you that way before. And so we get the vector 3v is the vector 9, comma, negative 6. So we can scalarly multiply vectors. We can opposite vectors. Okay? We can subtract vectors. Okay? And we can just do algebraically, we can subtract the vectors. Just like we added the vectors before. If I make this one be my red vector, then that would be negative 2 and 5. If I make this one be my green vector, then that would be 3 and negative 2. And so my u minus v vector would be negative 5, comma, oops, and not 3. 7. Graphically, we would have t, and then negative 5, 1, 2, 3, 5. That would be u minus v. Because if you think about it in terms of adding vectors, you would actually have to add the opposite of vector v. So instead of going head to tail, you would go head to head. Oops, not that. I want this. You go head to head there, and where the tail is, there's our vector u minus v. So what I would like you to do now is I would like you to do those 5 problems. I know there's only 4 up here right now, but there is a 5th one down below. It should be like that. Oh, it's fine. Yes, it's negative. No, it should be negative. Because it's just, instead of, it should be that.
Oh, it's negative 3.
Because t is negative 3. Yep. No, that's fine. Either way. Okay. So I get for the first one, I got negative 1 plus 2 is positive 1. 3 plus negative 5 is negative 2. U plus v is 1 comma negative 2. Yes? Love it. U minus v, I got negative 1 minus 2 is negative 3. 3 minus negative 5 is 8. So I get negative 3 comma 8 there. Love it. Tu, I got positive 3 comma negative 9 for that one. Yes? Love it. Okay. For this one then, I got the vector 4 comma negative 10, and then plus the vector 3 comma negative 9. That's going to give me 7 comma negative 19 for that one. And negative r times u, so that would be negative 2 times u is negative 1 comma 3. That's going to be 2 comma negative 6. Yes? That slide right there is very similar to this week's formative. Side note. Okay? That slide, if you understood that slide, that's your guaranteed 5 on the formative right there. Okay? Right? Now, let's go on. Let's dive more along head first into vector quantities. Okay? The magnitude of a vector, remember, was the length of that vector. Okay? It has a symbol, and that symbol is a double absolute value. Okay? That is the symbol for the magnitude of a vector. Okay? A double absolute value. Now, if we think about vector W here, okay, vector W is at negative 2 comma 3. So it's right in, somewhere in about there. Okay? If I look at it, I've got to find, for the component form, I would find that's my horizontal distance, correct? There. And then here, this is my vertical distance. Right? Well, what have I just really drawn? A right triangle. What do we have in a right triangle to find this missing side right here? If this side here is 2 and this side here is 3, How do I find that missing side? Pythagorean theorem. Exactly. So we would do over here, we would say that that circle is equal to, or that circle squared is equal to 2 squared plus 3 squared. And then we'd say that that circle is equal to the square root of 2 squared plus 3 squared. Right? Well, that's how we find the magnitude. The magnitude of V is going to equal the square root of x squared plus y squared if V is x comma y. And that's how we find the magnitude. So here then, the magnitude would be the square root of 2 squared plus 3 squared, or in this case, it would be negative 2 squared plus 3 squared. Negative 2 squared is 4. 3 squared is 9. So that's going to be the magnitude of V is going to be the square root of 13. And that's how we find magnitudes. Direction angle, remember, this is that trig angle. The unit circle angle, if you will, and it is going to bring back some painful memories. We're going to have to use referencing. Okay? Because if you think about it here, I'm going to expand this out a little bit just so that you can see it a little bit better. Okay? This right here is my direction angle of my vector. Okay? Which means then that this here is my reference angle. And I find that. So we go, the reference angle is equal to the inverse tangent of y divided by x, and we drop the negative signs. Because we want that reference angle to be acute. So if we would do that on a calculator, if somebody's got a calculator and could type that in, we should get here, verify for me, that we get a reference angle of 56.31 degrees. Yes? Okay. So we get a reference angle there. But because my vector is in quadrant number 2, my actual theta is going to be 180 degrees minus my reference angle. Remember, in quadrant 1, it's its own reference angle. In quadrant 2, it's 180 degrees minus my reference angle. In quadrant 3, it's 180 degrees plus my reference angle. In quadrant 4, it's 360 minus my reference angle. So this would be 180 degrees minus 56.31 degrees, which gives me a direction angle of W, and that's how we identify it. We put theta, and then in a subscript we put what vector we're finding. So the direction of W would be 123 degrees, 0.69 degrees. Okay? I I think now is a great time for you to try one on your own. Try this example, please. There's our vector. Find me the magnitude and its direction. So the magnitude, be the square root of 1 squared plus negative square root of 3 squared. That's going to be 1 plus 3. So that's the square root of 4. So the magnitude of u I get is 2. Do you agree? Okay. That's a good thing. Magnitude is 2. Direction angle. So theta prime, because I'm not in quadrant 1, I have to use a reference angle. So theta prime is going to be the inverse tangent of the square root of 3 over 1, which is 60 degrees. So now I just have to figure out which quadrant I am in. Positive, negative puts me in quadrant number 4. So that is going to be my actual theta is going to be 360 degrees minus my reference angle. So 360 minus 60 gives me a direction angle for u of 300 degrees. Agree? Love it. Given the magnitude, given the direction angle, that would put us, so if we had this would be a length of 6 there, and this would be an angle of 135 degrees. Yeah? Which would give me, would give me a reference angle here of 45 degrees. So if I needed to find the horizontal part, I would say that the cosine of 45 degrees is equal to x over 6, which means that x is going to be 6 cosine of 45 degrees, which gives me, I believe it is the square root, 3 square roots of 2 for x. Right? And then I've got to find the vertical component. We'll call it y. That would be the sine of 45 degrees is equal to y over 6. So y is going to be 6 times the sine of 45 degrees, which is going to be 2. However, what's the problem with that? There's one big problem with that. What quadrant is vector v in? Which quadrant is vector v in? 2, right? What do we know about all of the points in quadrant number 2? What's negative? What part? The x part is negative in them. Okay? So the actual component form of vector v, excuse me, I should put that in the proper color. The actual component, come on. That. There we go. The actual component form of vector v would be negative square root 3 over 2, comma, 3 square root of 2. For that. In general, the nice thing about vectors is that the magnitude, or excuse me, the vector v is going to be comprised of the magnitude of v times the cosine of its direction angle, and the magnitude times the sine of its direction angle. That's the quick and easy way to find that. Which makes it easier because we could have gone way back up here. I guess I can't go all the way back up. Now I can. We could have gone right to this, and we could have said that v here is 6 cosine of 135 degrees. That's comma 6 sine. And then the cosine of 135 degrees would have gotten us negative root 2 over 2. Sine would have been positive root 2 over 2, and so we would have gone directly to that answer. Okay? At the bottom of that page on your pink sheet, or excuse me, purple sheet, is an in general. I'd like to fill that in as the last thing we do here today. Okay? Ignore this part for right now. For right now, just kind of ignore that. We'll get to that tomorrow, the I and the J form. Okay? But x here, so the horizontal component is going to be equal to the magnitude of v times the cosine of the direction of v. Y is going to be the magnitude of v times the sine of v's direction. The magnitude of v is going to be the square root of x squared plus y squared. And our reference angle is going to be the inverse tangent of y divided by x. And we can't forget to drop our negatives. Whoo! Good time. We'll pick up on this tomorrow.